All right. Rationalize the denominator. Last thing on our foldable. If you need to go back and review any of this, remember you can find it on YouTube underneath Julie Prater. Just go to playlist, pick Algebra 1B, and then they'll be listed underneath there. I'll do rationalize, and then I'll type out, I'll name the video examples 27 through 30. So these are our very, very last notes that go on our foldable. So that means we'll be done with the new content of radicals. So what happens if you are dividing and your problem looks like this? So we ran into this a while ago when we had our whiteboards out, and I said, hey, we're going to talk about this later. This isn't something we've done yet. So if we have 1 over or 1 divided by the square root of 3, the square root of 3 has nothing to divide into. Y'all you understand what I'm saying? The square root of 3 can't divide into 1. So you're stuck with the square root of 3 in the denominator. We have 2 Algebra 2 students in our midst. I'm not sure if they're paying attention. Okay? But let me see if they can tell us what the rule is in this situation. You cannot have a square root in the denominator. From Unison Twins there. You cannot leave a square root in your denominator. It is like a rule. It's a mathematical rule that they'll arrest you and send you to math jail if you leave a radical in your denominator. Okay? Yeah. And I've not been to math jail, and y'all probably will never go to math jail either. It's not a real place. It's just imaginary. It's just fictional. Okay, so, y'all listen to me. So we're going to have to multiply by something that's going to make the square root of 3 go away, because we don't want the square root to be in our denominator. So what you have to do right now, when you get to Algebra 2, it's going to get harder than this. But right now, whatever is in the denominator, you can just multiply that over itself. Okay? So if the square root of 3 is in your denominator, and you know it can't be there because it's a square root, then you're just going to multiply by the square root of 3 over the square root of 3. That's legal because that's really a 1. Anything over itself really has the value of 1. So you're going to do top times the top. 1 times the square root of 3 is square root of 3. Bottom times the bottom. Square root of 3 times square root of 3 is the square root of 9. And then you're going to go, oh my gosh, the square root of 9 is a perfect square. And it's going to turn into just a 3. But you still have to leave the square root of 3 in the top. Who can tell me why I can't divide this 3 into this 3? This one's not under the square root, and this one is. You can't divide an outside number with an inside number. They don't get along. Okay? All right, let's look at another one. Example 28. 2 divided by the square root of 6. 2 divided by the square root of 6. We have a rule that says we can't have square roots in the denominator. So we're going to rationalize the denominator, which is just a really fancy word for saying that we're going to multiply by what? The square root of 6 over the square root of 6. So you just look at what's in your denominator and put that over itself, and that's what you're going to rationalize by or multiply by. Then you're going to do top times the top. What's 2 times the square root of 6?
12.
Just 2 square root of 6. You can't multiply 2 and 6 together because one's an outside number, one's an inside number. Bottom times the bottom gives us the square root of 36. That's always going to be a perfect square. If you've done this correctly, that number right there will always be a perfect square. So on the bottom, the square root of 36 turns into 6. On the top, you just have 2 square root of 6. Here's the question. Are you finished, or will this answer continue to reduce or simplify? No, you can't reduce the 6's because one's under the square root and the other one's not. But you can reduce 2 over, y'all with me? 2 and 6 are outside numbers, so you can reduce those. That's 1/3. So it'll be 1/3 square root of 6 is in the top. Okay, you probably won't see the 1. They'll probably just write that as square root of 6 over 3. You can put the 1 there if you want to. So if you weren't paying attention, what just happened is 2 over 6 reduced by 2 to be 1/3. You can leave it as 1 square root of 6 over 3. You can write it as square root of 6 over 3. All right, 2 more examples. 29. 7 square root of 5 divided by the square root of 15. Shh. 7 square root of 5 divided by the square root of 15. All right, before you get rid of the square root of 15, in this problem I have a square root in the top and a square root in the bottom, and 5 will go into 15. So go ahead and divide first if it's possible. So if I divide first, that's going to give me 7 over what? 7 over the square root of 3. If you can divide, go ahead and divide. You don't want to try to get rid of square root of 15 because that's a really big number. So if you can divide and make your number smaller, that's going to be more helpful for you. Can't leave the square root of 3 in the denominator. What am I going to multiply by or rationalize by? Come on. Square root of 3 over the square root of 3. So somebody's going, do you always use the number that's in the bottom? Yes, because that's the square root you're trying to get rid of. Top times the top gives me 7 square root of 3. Bottom times the bottom gives me square root of 9. That bottom number should always be a perfect square if you did the process of rationalizing correctly. So it gives me 7 square root of 3 over what? 3. Will 7/3 reduce? Will 7 over 3 reduce? No. Can the 3 in the bottom go into the 3 in the top? No, because one's an inside number and one's an outside number, so you're finished. All right, last example. Example 30. All right, what if your whole entire fraction is underneath the square root? If your whole entire fraction is under the square root, you want to think of that as 2 separate square roots. So if your whole entire fraction is underneath the square root, you want to tell me how to work it?
No, I have a question.
Okay, question. Okay.
Why if we have 7 square root of 5, we'll only multiply the 7?
Are you talking about from this step to this step? Okay, we divided the square root of 5 down into the square root of 15 first to make the number small. Okay? All right, square root of 7 divided by square root of 3. We can't have which one? The square root of 7 or the square root of 3? We can't have the square root of 3. There can't be a square root in the bottom. So what are we going to multiply by? Square root of 3 over the square root of 3. Top times the top. Square root of 7 times the square root of 3 is what? Square root of 21, good. Square root of 3 times square root of 3 is the square root of 9. Will 21 simplify? Is it a perfect square? No. Does it have any factors that are perfect squares? Nope. So you got to leave that as the square root of 21. Is 9 a perfect square? It better be. If it's not, you've done something wrong. Square root of 9 is 3. Last question. Will 3 go into not 21? Can 3 go into 21? No, because 3 is an outside number and 21 is an inside number. That's not really 21, guys. It's the square root of 21. So you can't divide the 3 into it. All right.